So we have two types of collisions, elastic collision na inelastic collision. Okay, elastic collision ni type ya collision ambapo vitu vinakuwa conserved, kinetic energy inakuwa conserved, potential energy inakuwa conserved, momentum inakuwa conserved. Momentum though zinakuwa conserved to both, lakini all others zinakuwa conserved. Okay, momentum zinakuwa conserved to both. Momentum is conserved for elastic collision, kinetic energy is conserved for elastic collision, potential energy is conserved for elastic collision, total energy is conserved for elastic collision. So in a special way tuna kitu tunaita coefficient of restitution. For elastic collision, coefficient of restitution is usually 1. Tutaona maana ya coefficient of restitution ni nini. However, for inelastic collision, coefficient of restitution is usually between 0 is usually not an 1 0. So any number that is not 1 in inelastic collision cha kwanza. Kinetic energy is not conserved for inelastic, potential energy is not conserved for inelastic, total energy is not conserved for inelastic, but the only thing that is conserved is the momentum. So I spoke of coefficient of restitution. What does it mean? Coefficient of restitution is actually the ratio of velocity of separation over velocity of approach. What does this mean? We have two balls colliding. Okay, they want to collide. Huyu anamfuata huyu, eventually they collide. They are approaching each other. So you have U1 and you have U2. But after collision, they have new velocity V1, V2. So they separate. Maybe after collision huyu anaenda huko, huyu anaenda huko. That's why after collision is what we call velocity of separations, and before collision is what we call the velocity of approach. So usually it's V2 minus V1 if you have two bodies. V2 minus 1 divided by, notice that this is V2, this is V1. And this is U1, this is U2. So notice the difference. This is how we get the coefficient of restitution. So it is usually 1 for elastic collision. It is usually 1 for elastic collision because kinetic energy is conserved. So conserving kinetic energy, you also conserve the velocities. So that's why the final, the initial, the summation, they are conserved. So they will be equal, it will be 1. But for inelastic, when it is less than 1, it is just a simple inelastic collision. But when it is equal to 0, this is perfectly inelastic. Perfectly not sense. It means they stick together. After collision, they stick together. So if they stick together, it means V2 is equal to V1 because they are sticking together, they are moving together. So V2 is equal to V1, minus inakuwa ni 0. So 0 divided by that tunapata 0. So when it is E is equal to 0, it means they are sticking together. It is perfectly inelastic collision. However, if E is less than 1, that is inelastic. You can ask yourself that if E is less than 1, it means either numbers za juu zinapungua kwa sababu that's the only way ambayo zita decrease the value ya E, au namba za chini zinaongezeka kwa sababu denominator ikiwa kubwa the number gets smaller. Sawa? And that's true for a normal collision. Ni kwamba initially zinakuwa na energy kubwa, zinavyo collide kawaida energy lazima ipungue, si ndio? So it's normal for E less than. But if E is greater than 1, E will only be greater than 1 if the velocity downward gets smaller and velocity upwards gets larger. Is there any such collision whereby zinatembea tu kwa speed ya kinyonge then after collision ghafla they increase the speed, because this is what it means when it is greater than 1. Then if we think normally sio rahisi kutokea, lakini kwenye explosion ndo kinachotokea kwamba coefficient of restitution becomes 1 kwa sababu whenever you have explosion, the speed inayotoka baada ya explosion au bomu linavyolipuka ni kubwa kuliko bomu lilivyokuwa lina move mwanzo kabla lijalipuka. Another point ya kuongezea ni kwamba when there is perfect inelastic collision, it means that after collision they have the same velocities. So it is either they stick together and they move, or they both stopped. So kwa sababu zote zikisimama, it means these values zitakuwa 0. So E when is equal to 0 is either they both stopped or they moved with the same velocity when they stick together. So dissipation of kinetic energy in completely inelastic collision when they stick together. Tutumia kesi ambayo ina stick together, so ile ambazo zote zina stop. So there are two ways. Kuna hii way ya kwanza na hii way ya pili. Hii way ya kwanza ina depend na some other derivation ambazo hazipo hapo. Kwa tutatumia hii law ya pili, okay? So we know change in kinetic energy is equal to kinetic energy ya final minus ya initial. Ya final I have m1 plus m2 because they move together, so the total mass m1 plus m2 times v final squared minus initial I have v1 squared, okay, times mass, walisahau mass 1 hapa, times mass 1. So we can eliminate EVF from here, that if we have momentum is conserved at least kwenye inelastic collision. So from here VF is equal to m1 v1 divided by m1 plus m2. So we can substitute this here. So instead of VF we put this value. So if this is VF square, it means the square of this value. Ndio hii hapa m1 plus m2 squared v1 squared minus 0 times m1 v1 squared, okay? So if we simplify this, we get our final expression as it is given there. So sometimes they usually ask us to show loss of kinetic energy. So I'm just giving you an idea. Here they might ask various questions depending na anataka nini. Anaweza kukwambia we express in terms of coefficient of restitution. So utakachofanya ni tu baada ya hapa utaiconvert in form of coefficient of restitution, utaingizia tu coefficient of restitution pale. Though kwenye inelastic collision ni zero, so kuingizia hapo inakuwa ni tatizo kidogo, but this is how tunafanya. Ukiambiwa calculate the change in kinetic energy, unachukua ile ya final minus the initial. That's how we usually do it, okay? So we have again what we call oblique collisions. Oblique collisions ni types of collisions ambazo zinaoccur at an angle, okay? Zinaoccur from an angle. So you find that we have a body moving from that point, another body moving from that point. They move and meet at this point, they collide such that body A, call it body 1, moves upwards and body 2 moves downwards. So oblique because they move at an angle. Na hichi ndio kinachoifanya hii part ya advance iwe tofauti, sawa? But issue ni rahisi tu, ni kwamba tu resolve principle, ni kwamba resolve conservation momentum, resolve for all bodies vectors initial and final. So the principle is that resolve momentum ya body 1 into vertical and horizontal, ya body 2 into vertical and horizontal, ya body 3 into vertical and horizontal, ya body 4 into vertical and horizontal. Finally utarudi kwenye formula conservation of momentum. Utaanza vertically, utakuja horizontally, finally shughuli inakuwa imeishia hapo. Kwa mfano we have body 1, umeona hiyo hapo momentum yake na move hivyo. So tukiresolve across horizontally, itakuwa ina direction is very important, okay? So unapo resolve kileta hapo utaona inageukia huko, kwa ni across, so tumia cos velocity yake. Ukiresolve velocity sasa tumeresolve momentum. Ukiresolve vertically inakuja kuwa u1 sin theta. Similarly kwa hii hapa unafanya hivyo hivyo, kwa huyu hapa unafanya hivyo hivyo, una resolve horizontal vertical, na huyu unafanya hivyo hivyo cross cos v2 cos b2, vertically inakuwa v2 sin beta. So finally huku na initially zipo huku. So finally you start comparing vertical versus vertical, the initial na horizontal versus horizontal, the vertical na horizontal. So kwa mfano horizontally ukiangalia hapa, you have initial momentum should be equal to final momentum. So initial momentum horizontally inaenda huko, na ya body 2 inaenda in the same direction, so just add them up. m1 u1 cos theta, because the velocity is this one, not u1 only, u1 cos theta. So m1 plus u1 cos theta plus m2 cos theta 2 u2 cos theta 2, okay, is equal to the horizontal ones. They move in the same direction, so it's the same that you add them together. m1 v1 cos beta 1, m2 v2 cos beta 2. You are done with the horizontal. Simple like that. Vertically, you consider, as you can see, downward is negative, is moving downwards, and the other body is moving upwards. It means hapa kuna minus lazima itokee hapa, sababu hizi ni vectors, so you can just assume kwamba positive ni kwenda chini. So positive kama ni kwenda chini, utaandika hapo m1 u1 sin theta 1, m1 u1 sin theta 1 minus, kwa sababu yanaenda oppositely, m2 u2 sin theta 2 is equal, tushasema kwamba kwenda chini ni positive, kwa kuja huku kwenda chini ni positive, so v2 m2 v2 sin beta 2 ndio itakuwa positive, kwenda juu ni negative, m1 sin beta 1 v1 inakuwa ni negative. Then you just equate and solve the answer. Just remember, you first resolve each, then you start comparing conservation momentum vertically and horizontally. When you are resolving, remember the directions. Directions are very important. When they oppose each other, assume one direction to be negative and use it throughout the question, and that's it. For mfano na swali, a smooth sphere A of mass 2 kg and moving with speed of 6 meters per second collides obliquely with the smooth of sphere B. Okay, so you have smooth sphere A, okay, inaenda ku collide na smooth sphere B. Hapo amechora tu hivyo to show the direction of velocity. Actually ilikuwa inaenda, so suppose iko somewhere hapo, kwa itaenda zita collide. So itaenda zita collide. Just before impact, B is stationary. This was stationary. Kwa ni kama tu ilikuwa inaenda, B was there, so imeenda ika collide. And velocity of A makes at an angle of 60 degrees with the lines of centers of the two spheres. Okay, it makes an angle of 60 between the line of center with the line of center. It means, so angle ile unaopewa ni muhimu sana, sababu angle ikiwa huku ni kitu tofauti. Sawa, the coefficient of restitution between the spheres is 1/4. Find the magnitude and direction of velocities A and B immediately after the impact. Okay, so initially una hiyo hapo, nimesema cha kwanza ni kuresolve. So ukileta hiyo hapo, utaona one component inageukia juu, na kwa sababu ukipiga hapo pap, inakuwa across, kwa horizontal component inageukia huku, ukipeleka huo mshale hapo pap. Sawa, ukileta vertically, chap, utaona mshale unageukia juu. Ndio hicho alichoandika hapo. Sawa, anyway, so alichoandika ndio hicho alichoonesha hapa. Hata hapa chini ni hivyo kwamba you have the horizontal one as u1 cos 60, and you have the vertical one because it is moving away, u1 sin 60. After collision, umeambiwa kwamba find the magnitude and direction of velocities A and B immediately after impact. So we assume that they keep on the sphere will be affected in such a way ambayo imeonyeshwa kwenye mchoro hapa. Sawa, ambayo imeonyeshwa kwenye mchoro hapa kwamba when ikihit, sawa, ikihit zitaanza kumove, kwa nakuja zina hit pap, afu zinaanza kumove. Huyu kukaa hivi, it means yeye anaendelea zake hivyo. Au akihit after collision, atasi huyu nienda kuja huyu body atamhit huyu pap, huyu atamove kwenda huko, the body will proceed moving that way. Huyu ambaye alikuwa na move ataendelea kumove. Ndio maana after collision huyu bado amebaki na, kwa sababu hapa kuwa 60 means hapa pia ni 60 degrees. Okay, so ndio maana huyu amebaki na components zake. Ukiresolve hii so na horizontally inakuwa v1 cos 60, vertically inakuwa v1 sin 60. Ndio maana imebaki vile vile, lakini huyu maana yake alivyo collide aliendelea kumove horizontally, maana yake hana vertical motion. Kwa after collision iko hivyo. Since B is stationary before the impact, moving along the line of centers after the impact. After the impact, they move along the line of the centers. So at speed after collision, it will actually be 6 sin 60. It's because the velocity won't be affected vertically. As you can see, it has kept on moving the same direction. What was only affected was the horizontal motion. Ndio maana ikamu affect na kuminduce huyu the sphere with horizontal motion. So vertically, speed after collision is equal to the speed before collision. Anyway, because there is no vertical motion after collision, so m1 u1 vertically there was no, it was at rest, and vertically after collision inabaki m1 v1. So ukiangalia m1 na m1 zina cancel, v1 inakuwa sawa na u1. Ndio maana hapa amesema there is no change. Sawa, there is no change after collision because there was no any movement after collision vertically ambayo ilikuwa induced in the second body. So the second body lacked vertical motion. So parallel to the line, horizontally now there is a change, because horizontally initially you have u1 cos 60. So you have 6 cos 60. Cos 60 is half. So 6 times cos 60 ni 3 initially. But again, after collision, remember this is 3 is just velocity. So to multiply with the mass of A is 2 kilograms. It's 2 kilograms. It's what they are writing here. 2 times 6 cos 60 is the momentum before collision, because for B there is no movement. After collision, we have 2 times V, mass of body, A times V, which is the horizontal component after collision, plus mass ya B, which was 4 kilograms, times velocity W, which is the horizontal motion of B after collision. We know from here that from the coefficient of restitution, V1 minus V2 over U2 minus U1. Okay, V1 minus V2 divided by U2 minus U1. Remember, initially, if we say now this is A, this is B, this is B, this is A. Initially, for body B there was no velocity. Okay, that therefore leaves velocity of A minus velocity of B as 1 over 4 times velocity of A alone. Okay, velocity of A alone. So which is because now we are speaking of the horizontal velocity, inakuwa ni sawasawa na horizontal initial velocity ya A ambaye ilikuwa ni u1 cos 60. u1 kumbuka ilikuwa na move na speed ya 6 cos 60 ni half, so inakuwa 3. So 3 over 4. Okay, 3 over 4 ni sawasawa na VA minus VB. Kumbuka this was negative from here. Okay, so in other words, VB minus VA itakuwa ni sawa sawa na positive now, because nimezigeuza hivi inakuwa positive 3/4. Ndio hicho alichoandika hapa. Sawa, 3/4 from Newton's laws of restitution. Therefore, we have one equation here and we have another equation here. So we can simply use the two equations to find the value of W and V. Okay, we have the two equations to find the value of W and V. So we solve this simultaneously for V and W and we get the answer. Combine the two components of velocity of A. Kwa vile hapa tukitafuta jibu tutapata value ya V, value ya V. So you can see nilishasema kama tail na tail zina join, then the resultant inakuwa ni inapita katikati. So parallelogram law. So baadaye tutafuta angle na utasema direction na velocity yako itakuwa ni hiyo. Najua utakuwa umechanganyikiwa kidogo, but don't worry. Sawa, tufanye mfano mwingine labda unaweza ukawa clear zaidi. A smooth sphere A of mass 1 kg. A smooth sphere A of mass 1 kg collides with a smooth sphere B of mass 2 kg. Only the principle ni ile tu ambayo nimekuambia. Don't worry all the rest. Just do the right thing. That's the most important thing. Just before impact, A is moving with speed of 4 meters per second. So A moves with speed of 4 meters per second before impact in line of direction at 45 degrees. Okay, to the line of centers. And B is moving with speed of 3 meters per second at 60 degrees to the line of centers, as shown in the diagram. The coefficient of restitution between the spheres is 3/4. Find the kinetic energy lost in the impact. And second, the magnitude of the impulse exerted by A on B. So kinetic energy lost in the impact is equal to just the final kinetic energy minus the initial kinetic energy. So again, if we just resolve, ukiresolve hii umeona hii inaenda juu. Okay, inakuwa ni 4 sin ya 45, while ukiresolve huku inakuwa ni 4 cos ya 45 kwa sababu it moves across. Ukiresolve hapo ukileta huku inaangalia juu inakuwa ni 3 sin 60. Ukiresolve ukaleta hapo inakuwa inageukia that direction, kwa na kusomana ukileta hapa inageukia that direction, kwa inakuwa ni 3 cos kwa sababu ina cut across cos ya 60. Okay, yes. So after collision, so they come and collide, so they go back that way, that moves away, that moves away, that moves away in the same direction that they were coming from, but in upwards. Okay, because zinaenda downwards to the right, zina collide, zinaenda in the opposite direction. So zina collide, hiyo anaenda left, hiyo anaenda right. Ndio hichi kilichotokea hapa. Sawa, kwamba huyu alikuwa na enda right, huyu alikuwa anaenda left. Sawa. So always as usual, there is no change in the component perpendicular to the line of centers. So usually there is no change of line, no change of components perpendicular to the line of centers. So they usually remain intact. So they usually remain intact. So there is no change in that. There is no change in that. So suppose, because our question here is to find first the velocities after collision, because we don't have the velocities after collision. So we are supposed to find the velocity after collision first before we find the loss of impact energy lost in the moment of impact. So parallel to the line of center, tukiconsider horizontally, tuna initial momentum ya mass ya A ambayo ilikuwa ni 1 kg times velocity ya A horizontally, so 4 cos 45 times 1 kg, so 4 cos 45 minus, kwa sababu umeona huyu anaenda in opposite direction, huyu anakuja hivi, huyu anaenda huku, so we assume that this one is going opposite, so minus mass ya B ambayo ni 2 kg times 3 cos 60, 2 kg 3 cos 60 is equal to momentum after collision horizontally. Okay, so we know that the horizontal component assume ni hivi na horizontal component assume ni hivi. Kwa yani hapa ni kama zilivyo collide zikaenda huko, we assume kuna angle hapa theta na kuna angle hapa beta. We resolve the angle hapo, tunapata vertical component after collision, but we have said they don't change, so the values remain the same. So what changes are only the velocities horizontally. Okay, what changes are only the velocities which move horizontally. So after collision we have V. Okay, as we said E direction ni negative, tulishasema E direction ni negative, kuna kwa minus V, kondo hapa minus V again times mass ambayo ni 1, ndio imebaki V peke yake. Again for W ambayo ndio horizontal component ya after collision ya B, mass ni 2 kg times velocity ya B ambayo tumesema nini ni W. Okay, kuna kwa 2W inaenda that position, ndio tulishasema ni positive tangia huku mwanzo, positive to the right na kwa positive, ndio maana hapa ilikuwa positive, hapa to the left imekuwa negative, but after collision ya A ndio imekuwa inaenda to the left, kwa ndio imekuwa negative. Kwa remember to the left ilikuwa negative, kwa ndio maana we say directions are very 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 important. Okay, yes, so we have this equation here. Again E tumeshasema ni VA minus V B over UB minus U. Tumeshasema kama hapa ni A, hapa inaanza B, therefore VA minus VB ni sawa na E ambayo ni 3/4 times UB horizontally was acting that direction, 3 cos 60, so it was 3 cos 60. However, it was minus, since it was, we said that direction is minus. Minus UA, so UA we know ilikuwa ni in that way, it was positive, so there is no problem. Minus 4 cos ya 45. Okay, but remember also finally they go the opposite direction, so VA was minus after collision, so finally ukimultiply by negative throughout kuondoa minus, nakuja kupata VA plus VB is equal to 3/4, kwa zote zinakuwa positive huko ndani. Mwana negative inakuwa positive, negative inakuwa positive. Ndio hicho alichoandika hapa. Sawa? Ndio hicho alichoandika hapa. Kumbe unajifunza nini? Kwamba katika maswali ya collision, direction ni very very important. Okay? Direction ni very very important. Ukishaleti kitu fulani negative, kinakuwa ni negative throughout kwenye expression ya restitution, kwenye expression ya momentum, kwenye expression sphere, wapi popote hapo involve vectors. Sawa? As long as umesha assume ni negative, inakuwa ni negative throughout. Again, remember vertical components who has you affected in coefficient of restitution. Coefficient of restitution ina apply only for horizontal motion. Therefore, we have the first equation and the second equation. So we use the two equations, we solve for V and W, and we get our answers. After we get V and W, then we can calculate finally our velocities. Okay, we can finally calculate our velocities. That kinetic energy lost by A Okay, because vertically there is no change in velocity, so kinetic energy tukitumia vertical components hatutapata precise answer. Ni vema either tutumie horizontal component kutafutia kinetic energy au tutumie resultant velocities. That's the only place ambapo tunaweza tukapata kinetic energy ambayo iko sahihi. Change tunaweza kaipata is either we use vertical components, horizontal components or the resultant. Kwa tukipata hapa tungeweza kutafuta resultant, tukatumia na hizi resultant tukatafuta kinetic energy change. Lakini kwa vile tuna complicate tukienda huko, ni tutatumia tu horizontal kwa sababu tunazo tayari. Kwa tutaangalia horizontal before after collision minus the one before collision, then we can calculate the change. So kinetic energy before collision, kinetic energy after collision, na calculate kinetic energy by B before collision and after collision we put. So after collision it was 1.5, so 1.5 squared, as you can see here. That's what we got. 1.5 was the velocity before collision. So we take the velocity before collision, which was 1.5. Anyhow we are going to do it, but just we need the difference. So being negative, positive doesn't matter really, but make sure it's just positive. So you take ile kinetic energy kubwa, usually you take before collision kwa sababu velocity inakuwa ni kubwa, minus after collision. Kwa ndio hizo alizo fanya hapa, before collision and after collision. So we put them here, get the kinetic energy lost. Impulse, we know impulse is just the change in momentum. Okay, impulse being the change in momentum, impulse, you remember, force times time is equal to change in momentum, mv minus u. So since tumeulizwa impulse exerted by A on B, it means A alimsababishia huyu B kuchange momentum. Sawa, huyu A alimsababishia B kuchange momentum. So changes in momentum of B. So magnitude of impulse exerted by A on B. So tutatumia changes za B kwa sababu huyu A alichokozi ni changes ya hiyo momentum. So tunatafuta hiyo change in momentum ambayo A ali-exert kwenye B. Okay? So we have final velocity of B minus initial velocity of B. So we know that the final velocity of B was 1.0249. But remember, the final velocity of B was positive. Okay? Was positive. Which is going to the right ni positive. So we have a positive here, 1.0249. Then minus initial velocity. Initial velocity was 1.5. As you can see here, initial velocity was 3 cos 60. So now na resolve hapa horizontal. Initial velocity was 3 cos consistent, half times 3 ni 1.5. But remember ilikuwa inaenda to the left, kwa inakuwa negative. Kwa negative 1.5, kwa inakuwa plus 1.5. Ndio maana hapa amesema change momentum along the line of centers. Don't forget that the direction changed on the impact. So finally the impulse inakuwa ni hiyo. Along there, these examples you can try and solve. Okay, you can try and solve these examples, but nataka unote vitu vitatu apart from maelezo mengi ambayo yanachanganya. The first thing you should know ni swali tunafanyaje. Tuna resolve, tunatumia principle of linear momentum. Kwa tutaangalia vertically na tutaangalia horizontally. Hii ndio swali zima linasolviwa hivyo. Okay? So katika process ya kusolve, note the second, tunatumia equation mbili. Sawa? Equation ya kwanza ni equation ya conservation of linear momentum. Okay? Equation of conservation of linear momentum. Equation ya pili tunatumia restitution kama tumepewa. Equation ya restitution. Cha tatu, note vertical component is usually unaffected. Cha nne, direction. It's very important. Ukisha note direction fulani ni positive, basi kila kitu ambacho utatumia kinaelekea kwenye hiyo direction, utatumia positive. Be it kwenye formula, be it kwenye application, popote pale utakapokitumia kinakuwa positive. Kama the opposite direction ni negative, popote utakapotumia momentum, velocity, zinazo act in that opposite direction lazima ziwe negative. Sawa? Hivi ni vitu vinne ambavyo inabidi unote kama unataka kupata maswali yako kwa usahihi kabisa. Otherwise, find questions and try. They are not meant to be very difficult.